Hello, fellow students. Today we are going to talk about vectors. So the first thing we're going to talk about is the scalar product of two vectors. The scalar product, also known as the dot product or the inner product of two vectors, results in a scalar answer. So if you have two arrows given to you, the scalar product will give you a number. And this is defined as A dot B equals to the sum of all the components of the vectors times together and then add them all up. So a1 b1 plus a2 b2 plus all the way to an bn, and this is in an n-dimensional Rho vector space. So the number of terms here, how many terms, will be equal to the number of dimensions you are working on. And this scalar product works in any dimensions. So for example, you have two vectors in 3 dimensions, as it has 3 components here. The dot product will be equal to this formula. So what this means is you take this one times this one, the first component, multiply them together, and then you plus this one times this one, and then plus this one times this one. So you take all the corresponding components, times them together, and plus them all together. And then you also need to know some important properties of the dot product. The first one is they are commutative. So a dot b equals b dot a. It does not matter of the order you put them in. As you can see here, a dot b will be this one, a1 b1, and plus all the other terms. But b dot a will be b1 a1, and then these two multiplication does not matter. As you know, 1 times 2 is same as 2 times 1, so the order does not matter. And the second property is the definition of the magnitude. So the magnitude of a can be defined as the dot product of a with itself and then take its square root. So in 3 dimensions, the modulus of a can be defined as this. So it's a1, which is same as a1 squared plus a2 squared plus a3 squared, and then you take the square root. This is basically what you get when you use your Pythagorean theorem in the 3 dimensions. And then this is in the normal IJK basis system, as the one you will see right now there. And the third property is the distributive of the dot product. A dot b plus c is the same as a dot b plus a dot c. So you can basically expand the bracket. And a dot b dot c does not exist, as you cannot dot a scalar with a vector. So you know a dot b will give you a scalar. That's why it's called a scalar product also. And then you cannot dot this scalar with another vector c. The dot product does not work that way. You can only have 2 vectors dot together. And the last point is the geometrical meaning of the dot product. So it says the dot product will be equals to the modulus of a times the modulus of b, then times the cosine of the angle between them. So it's this angle. You need to beware of the angle. You need to start from the tail of one vector and then also the tail of another vector. You cannot have, say, for example, b here and there. This angle is not the angle between the vectors. It's defined as this angle. So let's do an example. If u is this and v is this, find the angle between the 2 vectors using the definition of the dot product. So the definition is this one, the geometrical one, as you need to find the angle here. And you rearrange this equation to find the angle. You divide these 2 modulus over, and then you get cosine of the angle equals to a dot b over mod a mod b. And then you calculate a dot b using the usual way. So the first component times together, plus the second component times together, plus the third component times together. You get your numerator here. For the denominator, you calculate your modulus of a first. And this a and b here is u and b here. They are just different names. It doesn't matter. So the modulus is this one squared plus this one squared plus this one squared, and you take the square root and times by the modulus of the second one, and it's the exactly same process. And then you calculate this. This will give you 4. This gives you 6. This gives you -2. And this 16, 4, 1. 1 plus 9 plus 4, and then after you work all this out, you get 8 over 200, square root of 294. But beware, this is the cosine of the angle, it's not the angle itself, so you don't write this as your answer. If you write this as your answer, it's surely going to cost you 1 mark. To find the angle itself, you need to take the inverse cosine of this thing. And then after you use your calculator, take the inverse cosine, and then you get about 62.2 degrees. This is the angle between the two vectors.